Hi again. So we're going to pick up where we left off on the space-time diagram. So if you recall, we were looking at two frames of references. We have Axel and B, where B is traveling relative to Axel, and she is traveling at 60% the speed of light and trying to go to some destination that's about 3.6 light years away. So we looked at what B's space-time diagram looked like from Axel's frame. And it was pretty straightforward. So I have here a simulation that's going to look at this, because what we want to eventually do is, what does B see happening? We know that what B sees, sounds strange, is different than what Axel sees. And we did some calculations in algebra, but we want to show how a space-time diagram can do the same thing. And in general, you know, from what I've listened to and heard, this is generally maybe an easier way to figure things out. But again, that depends on you. So I've got this simulation set for 6/10 the speed of light. We're going to start with the coordinate system of Axel, and we're just going to run, okay? And so what we can see here, which is nice about this, is we see the Earth along the horizontal or vertical axis, and then we see what the spaceship does with time, okay? And we can see, and again, this is a little bit difficult because maybe I can annotate here, okay, is that we can see that if this represents here Axel's time, here's 1 year, 2 years, 3 years, 4, 5, 6, 7, 8, right? And in fact, we know that from Axel's frame, it took 1, 2, 3, 4, 5, 6. It took 6 years for B to get to her destination. Okay, so if we go over to where she is right around here, we should see that it's 1, 2, 3, 3.6 light years away. Okay, so that's what we expect. But if you look at the spaceship, this represents B's frame. Okay, we can see that if you look at the gaps between times, they're different. They're longer, like we expect. So what we want to do is transform this coordinate system from her frame. And to do that, you need to do essentially a Lorentz transformation. Now, we're not going to do the formal Lorentz transformations here. There is a shortcut for that, which we'll talk about in the notes. But let me just kind of do a qualitative discussion. And by the way, the green line here is the speed of light, right? You notice that that's at a 45-degree angle, so that's kind of like the limit. There's no way she can move through space-time. And if she started, whoops, I guess I'm going to turn that off. If she started at 0 and be below that, because that would be traveling faster than the speed of light. Okay, so this is what's important. It's a very subtle idea. I'm not going to explain it very, very well, but the idea is, in B's frame,